Welcome to OnSoftware. Conversations with thought leaders in software development. Brought to you by
You're well known for your publications, your presentations. You've been a leading figure in the C++ world for a long time, and I can attest to that because I remember reading Effective C++ many years ago. First edition, of course. But what a lot of people don't know is that you really haven't spent a lot of time in the trenches as far as a production programmer. You have a PhD in computer science from Brown. And so what I would like to ask, kind of a two-sided question, how did you get into C++ and get into this role that you are in the C++ world? And then the flip side of that is, do you think that your perspective gives you, the fact that you're not an in-the-trenches programmer, but you do have, the background that you have, gives you a little bit of a unique edge that we don't commonly see in other contributors?
Well, I just want to point out, I actually did work as a software engineer before I went to graduate school. So I was, in fact, in the trenches, not for a huge amount of time, but I did work in the trenches for a while. I was responsible for delivering software. I did work all night long. I did drink large amounts of caffeinated beverages, so...
But therefore you're an official software developer.
I have, in fact, done that whole thing.
Okay.
The way I got into C++ is I was in graduate school and I had the TA course on software engineering, and the professor who was doing the course decided he wanted to use C++ because he thought it was a better software engineering language than C, and since I was TAing the course, I had to learn how to do C++. So that was originally how I got into that, and that was in 1988. Okay. And then at about the same time, or maybe a couple of years later, I became familiar with the fact that there's an industry of companies that send training individuals out to professional programmers to give them training on whatever the language might be. So it might be shell programming at that time, or C programming, or whatever. And the thing about those companies is that they need a large number of people who are extremely technically proficient, but who do not want to be employees, and yet who can take a week off at a time whenever a job arises so they can go someplace and teach, and who don't charge very much money. And graduate students are perfect for this. And so I started teaching a couple of courses on C because I would make more money in 2 days doing that than I did in a month as a graduate student, which was an attractive proposition. And then they said that they wanted a course in C++, which I knew, and so a friend and I developed a course in C++, and that's when you really learn a language, is when you try to teach it. And then I went out and taught it a few times. And
you liked it?
And I liked it. It was an interesting change. And I would teach week-long courses in C++, and usually by the end of the week, you had all these former C programmers whose heads were just swimming in all these new details. And so on Friday afternoon, I would sit them down and I would say, look, it's not that bad. Really, this is all you need to remember, just these 5, 10 things. We would write them down on the board. And after a while, people said, you should really write a book. And I said, no, you can't write a book. And after it happened a few times, I said, well, maybe I can write a book. And that's actually how Effective C++ got started. It was literally just these things that I had been writing on the board. That was the gist of the book. And I had been doing this so often and knew exactly what I wanted to say that I actually wrote a third of the book in 2 weeks, in essentially final form, because I knew exactly what I wanted to say. It has never been that easy since. But so anyway, that's how I got started in C++. Now, as regards sort of the background that I have and the perspective that I bring, the fact that I worked as a software engineer, it helps tremendously. Although it was a long time ago, there's a lot about software engineering and programming on a daily basis which really hasn't changed a whole lot. So I can relate to what people are doing, although the tools that they're using now are different from the tools that I was using when I was doing it. I will say that having a background in formal computer science helps in some kind of surprising ways, because a lot of programmers, for example, they don't understand the difference between what a compiler does, what a linker does, what the runtime system does, what the operating system does. And as a result, they will sometimes be looking in the wrong places to try to fix certain kinds of problems. So when you have it's not so much that I have a PhD in computer science, but the fact that I spent a lot of time academically studying a large number of areas of computer science, that allows me to bring a perspective that a lot of working programmers don't have. And so I think it just works synergistically with the experience they already have.
Right. Let's talk about C++ for a little bit. Just last night, I was at dinner with some C++ people, and we were talking about others' perceptions of C++. And I can't really count the number of times I hear comments like, oh, you mean C++ is still being used? Or why would you want to use C++? And for other communities that will remain unnamed, we do see and hear a lot of this talk of C++ is dying a slow death, which seems to be uninformed. How would you respond to that, and where do you see C++'s impact in software engineering today?
I'm a great proponent of choosing the right tool for the job. C++ is a tool. And C++, compared to other modern programming languages, is a big, complicated tool that is difficult to learn how to use correctly. So there has to be some kind of motivation for choosing this big, complicated tool that doesn't have some of the features that newer languages do, like garbage collection and runtime reflection and very fancy IDEs and huge class libraries. There's got to be a reason why you would turn your back on all of that and instead choose C++. And my feeling is C++ has been and will continue to be the language of choice for what I call demanding systems applications. And the operative word there to me is demanding. There has to be some kind of constraint that is difficult to fulfill that you have to absolutely meet. Usually it's performance. So it might mean the program has to go as fast as it possibly can. Sometimes it's space. It has to fit an extremely small amount of memory. Sometimes it's compatibility with an existing C API, where C++ naturally talks to C. Sometimes it's we have an enormous amount of data that's already laid out in a particular kind of format, and we have to be able to read that data using data structures which map exactly to the format. And C++ gives you control to do all of those kinds of things. So if there's some kind of demand that is difficult to fulfill, then C++ is a really good language for that. And I have to say, I take a certain degree of solace in the knowledge that some things have to run really fast. And as an example, if you are the person writing the just-in-time compiler that generates the executable instructions for a Java program or any .NET program, most just-in-time compilers for Java are written in C++. And the just-in-time compiler for .NET is also written in C++. Because when you're running these other languages, it's very important that you generate the best possible code as fast as you possibly can, because you are actually stealing cycles from the application itself in order to generate the just-in-time code. And that's a perfect fit for C++. It needs to be really, really fast. You can never go fast enough. And there's lots of other application areas too, but I do think it's interesting that these other languages tend to be implemented on top of C++.
Well, and that's what C++ is made for, right?
Yeah, like I said,
a systems programming language. And, you know, with the increase in hardware, sometimes we'll hear people say, well, we don't really have to worry about performance because we'll just get more memory or processors get faster, but the demand is always there. I think demand is a good word. What are some other examples of applications like that? For example, the embedded world seems to be catching on.
I think the embedded world is a natural fit. I happen to think that I think embedded systems development is going to be the next big area for C++. That's my personal opinion. Because embedded programmers, generally speaking, they have a limited amount of hardware. Usually you want to pay for the slowest processor you can get away with and the smallest amount of memory you can get away with, because you're going to be shipping a large number of units, which means you naturally want a language which doesn't need a lot of CPU power and doesn't need a lot of memory to get the job done. So if you have a language like C++, which gives you great control over how you use your resources, it just is a really natural fit. A lot of embedded systems also have to talk to hardware. C++ is a great language for talking to hardware because you can control the bits and the layout and all that kind of good stuff. Yeah. So, like I said, I think that embedded systems is going to be, I think C++ will become the language of choice in that whole area.
For more information, visit onpodcastweekly.com and subscribe to all our podcasts. Brought to you by the publishing imprints and information portal of Pearson Education.